All right, geometry crew. Hopefully everybody had a great Easter. Welcome back. We are starting today with volumes of prisms and cylinders. Now, I always say volume is going to be easier than surface area. All right, so this section is actually pretty easy, and the formulas for finding the volume of a prism, all right, so volume of prism is just whatever the base is, all right, whatever the area of your base is times the height. And the bases are always, whatever the figure or polygon is, because remember, your lateral faces are always going to be rectangles on a prism. So you need to find the area of just one of the bases multiplied by the height. And I always say, remember, cylinders, cones, those types of things are easier. So the volume of a cylinder is the same thing. Area of the base times the height. But because the base of a cylinder is always going to be a circle, you can write it as pi r squared times h. Okay? So let's do a couple of these problems. They're relatively simple. I'm just going to do the first two problems on page 721. And the first problem is a rectangular prism, all right, because our base is a rectangle. So I'm going to attempt to draw this kind of like how they do in the book. All right, so obviously the dotted lines are the lines that we really shouldn't be able to see if this was a solid figure. So there's our rectangular prism, okay? And they give us some pieces of information. They tell us that the height is 3 feet. This depth here is going to be 3 feet as well. And the length is 6 feet. So all we're doing here, we are finding the area of this base. And then we multiply it by the height. It's kind of like you take the area of that rectangle and it's oh, how many rectangles can we fit inside of this solid figure until we get to the top, which would be the height. So with this problem, we're going to take the area of our rectangle, which is just length times width. So 6 times 3, that's the area of the base, 6 times 3, and then the height is also 3, okay? So the volume here is going to be 9, 3 times 3 is 9, times a 6, so 54, now watch what I do, feet cubed. We're no longer in the squared dimension. We're now three-dimensional as far as basically how much water could you fill into this prism, all right? So 54 feet cubed. That is the total volume, all right? How much space does a solid three-dimensional figure take up? That's what volume is. But I do like to think about it as a liquid, all right? How much water or whatever liquid you're going to, use would fill up a cylinder or a prism. All right, so that was number one. That one's pretty simple. All right, let's do number two. Now, number two, we have ourselves a cylinder. All right, we have a cylinder. So let me see if I can draw this as well as the book did. Remember, a cylinder is kind of like a Pringles can. All right, that's not bad. So a cylinder is like a Pringles can or pop can, whatever you want to do. And they actually tell us the radius is what? 3 inches. And the height is 12 inches. So we now need to find the volume of this cylinder. Remember, the volume of a cylinder is the same as a prism. It's just we can write it like this because the volume of the base is always going to be a circle. So the volume of the base, pi r squared. So our radius is 3 times our height, which is 12. So we have now I don't know if this problem tells us, oh, it says to round to the nearest whole number. So they don't want us to leave it in terms of pi. All right, so what I'm going to do, 9 times 12, and then multiply that by pi. So if they want it to the nearest whole number, 339.3, so it's just going to be 339, and this is inches cubed. Okay? Sometimes they'll tell you to leave it in terms of pi. Sometimes they'll tell you to round to the nearest tenth or whole number. So just pay attention to the directions. Now, the last thing that I wanted to talk about, because your homework does go up to problem 20. All right, and if we take a look at the textbook here, these problems are called composite space figures. So these aren't perfect cylinders or prisms, but it's still a simplistic problem. What you would do, all right, first for this backpack problem, you would find the area of this rectangular prism. You would find the volume of this rectangular prism that is the base of this backpack. And then you would add to it the area, okay, the area of half of a cylinder, because that's what the top would be. And you would do the same thing with this problem down here, okay? And over here, you can either cut this top part off or maybe cut this part off here, and you would find the area of those two prisms and add them together. So that's how you do a space figure. But do notice, all right, do notice how this is half of a cylinder. It's not a full cylinder, it's half of the cylinder, okay? So the radius of this cylinder would be 6, all right, right? 6, because if this is 12 down here, half of that would be 6, and that's half the radius. So let's just say like the distance here is 6, okay? That means this height of your rectangular prism is going to be 11, because 17 minus 6 is 11. All right, so hopefully that helps you with this one too. But it's actually a pretty simple section. So hopefully everybody's staying healthy, and hopefully everybody had a nice, happy Easter.